So we want the graph of f of x equals x squared over 2x minus 3. So the first thing we did is we realized that we had a slant asymptote here because the degree in the numerator was greater than the degree in the denominator. So we did long division. And when we do long division, you do end up getting a remainder here, but the remainder, as far as curve sketching is concerned, does not play into how the graph goes. And it does not play into the slant asymptote at all. Here is your slant asymptote. It's 1/2 x plus 3/4. So, let's go from here. Let's find our intercepts. Okay, slant asymptote, is there horizontal asymptote? I'm sorry, find a horizontal asymptote and then our, so a horizontal asymptote is 2x minus 3 equals 0, so x equals 3/2. So over here at 3/2, we've got us a vertical asymptote. All right, now intercepts. Plug in 0 for x. This will give us our y-intercept. Plug in 0 for x, what do we get?
0.
0, right? So we got the point 0, 0. Now we set the equation equal to 0 to find our y-intercept. I'm sorry, that was our y-intercept. To find our x-intercept, but we end up seeing that there is only one intercept here, and it happens to be that same number. So 0, 0 is both our x and y intercept, and it's the only intercept that we have in this problem.
Yay.
All right. Well, actually not. The more points we can get, the better we're going to be.
Ooh.
There, that's better. All right. Now, next we want to talk about is where are we increasing and where are we decreasing? And to find that, we take the derivative. So f prime of x is 2x minus 3 times 2x minus x squared times 2.
All over 2x minus 3 squared.
All right, so from here, f prime of x equals 4x squared minus 6x minus 2x squared all over 2x minus 3 quantity squared. So we've got 2x squared minus 6x all over 2x minus 3 quantity squared.
You can take out the 2x.
Yeah, let's factor out. Okay, now we're going to set it equal to 0. So we, again, the denominator at 3/2. The numerator, factor out at 2x. So we get x equals 0 and x equals 6. No, x equals 3. I factored out a 2x but left that is a 6, and I knew that was not looking right. Okay, so we get x equals 3. I knew basically this was going to be my halfway point. So if this is 0 to 3/2, then it would be past that another 1.5. So it should have been at 3. That's the reason I knew 6 was wrong. Sometimes you just got to look at things to see if you've made a careless mistake or not. All right, so let's put these values on a number line and consider where we're increasing or decreasing. Okay. Now, remember, in this case right here, as long as the denominator's not 0, we're going to get a positive number because we're squaring a non-zero number. Okay? Now, let's think about -1. 2 times -1 is?
-2.
Mhm.
-1, -4, so it'll be 8 on top.
Mhm. So it's positive, right?
Yes, sir.
So we are increasing. Okay.
Top, it will be, for the next one, will be negative. For the top.
So we're decreasing.
Yes.
Hold up. Oh, all right. I'm sorry. I left off 3/2.
Oh.
That doesn't change things though.
Okay.
Okay. Between 3/2 and 3, we've got 2.
Yes.
So we still get it's decreasing, right? Okay. And then from 3 to infinity, if we plug in a number greater than 3,
It'll be positive.
so we are increasing. Okay. Now, we know the point 0, 0, 3/2 is our asymptote, but what is f of 3? Well, that's going to be 3 squared over 2 times 3 minus 3, which is 6 minus 3, which is 3, so 9 over 3 is 3, right? So we've got the point 33. So that puts me right there. So at this point right here, I've got 2 extrema. This, of course, would be a relative, what?
A minimum.
Actually, maximum. We go from increasing to decreasing. Relative maximum. Here at 3, we go from decreasing to increasing.
Relative.
That would be a minimum.
That's your relative minimum, yeah. All right. So now let's go to the second derivative. And second derivative, I'm going to take the derivative from this step here. So f double prime of x is 2x minus 3 squared times what here?
Squared.
4x minus 6? Okay.
I'm confused which one you did. Oh, the.
I'm going from this step here.
Oh, and so.
Oh, do you have
Minus, huh? 2x squared minus 6x. And then d low. 2 times
2x.
2x minus 3.
No, it'd be, would it not be 2 times? Oh yeah, 2 times 2x minus 3 times 2, so 4 times 2x minus 3.
Yeah, it's going to end up being 4 times 2x minus 3. I just wrote it like that though.
And then square root of
Okay, so at this point here, let's factor out what we can. All right. I'm going to factor out just a 2x minus 3. could factor out more, but. And then what's left over here is the 2 times 2, so that's 4. So it's 4 times 2x squared minus 6x. That's over 2x minus 3 to the 4th power. All right. Now, I'm unfortunately going to have to come back over here, so I'm going to erase this. So this 2x minus 3 will make one of these go to the dodo birds. So we've got 2x minus 3 times 4x minus 6, so we distribute in. So that's going to be 8x squared. Let's see, minus 12x and minus 12x is minus 24x. And then we have plus 18. And then it's going to be minus 8x squared. And then plus 24x. All over 2x minus 3 quantity cubed.
Well, it would just have 18 at the top.
Say that again.
It would just be 18 at the top.
So you're just left with 18 at the top and 2x minus 3 cubed in the denominator. And we want to consider when that's equal to 0 or when that is undefined. It will never equal to 0 because the numerator is 18 and 18 will never equal to 0. But again, we get x equals 3 halves. Once you get an asymptote, it's just there to stay. All right, so let's see, we are on the number line 3 halves, so we got 0, we got 2. All right, 0, a negative value cubed is negative, so we're concave down. And number greater than it, like 4, positive, concave up. So, let's get our chart up here. In our chart, what numbers do we want?
Is 0,
3,
3 over 2?
3 halves.
3.
Yeah, just 3. Yeah, yeah, 3 is the point, but we just need the x value there. Yeah, so it's 3. So we got f prime of x and f double prime of x. Negative infinity to 0. 0 to 3 halves. 3 halves to 3. And 3 to infinity. All right. We increase till we get to 0. Then we decrease, and again, I'm looking over here. We decrease between 0 and 3, right? And then we increase once we pass 3. Okay, and all that came from here. Now for the concavity, we look at this number line that we already solved out. It's concave down up to 3 halves. And it's concave up. And from there, increasing and concave down, looks like that. Decreasing and concave down, looks like that. Decreasing and concave up. Increasing and concave up. So, it's about to get sketchy. Because we're Sketching.
Uh-huh.
All right. So, we are here. And then we hit a slope zero. Again, you can't really tell too much out here about its concavity, but you've also got to hug that asymptote. Now we start decreasing once we pass zero. And stay concave down, so again, it's got to hug that asymptote. All right, now we decrease to the 0.33, and we've got an asymptote here, so we better be starting up here, and we're taking on this shape right here. So, and then once we hit here, we start increasing and concave up, but we've got an asymptote here, so again, it's not going to be anything super drastic. It's going to look like that. Are we good with this?